Bismillahirrahmanirrahim. Assalamu alaikum and hello to everyone. So in this lecture we are going to discuss about the nomenclature associated with the geometrical isomerism we were discussing in the previous lecture. So if you want to know what is geometrical isomerism, you must watch the previous lecture in which I have discussed the core concept behind geometrical isomerism, how it arises. To recall, geometrical isomerism is the type of stereoisomerism which arises due to the restricted rotation of sigma bonds. So, for the geometrical isomers, there are two types of nomenclature which are used. First one is the Cis Trans Nomenclature, and the second one is the E Z Nomenclature. You must have heard about the Cis Trans isomers, so it is a very common term and it is a classical and a very basic nomenclature which is also taught at basic level. So let's discuss cis trans nomenclature shortly. For cis trans nomenclature, it is only applicable on the cases where the two substituents around a double bond are hydrogen atoms. The other two substituents can be any. Let's say we have case like this. These A and B, they can be any group or any substituent. So two cases can occur. First case in which these two substituents they are on the same side, and for the second case, these two substituents they will be on the different side. So the concept behind cis-trans isomerism, cis-trans nomenclature, is very simple. For the case where the two substituents are on the same side, it is the cis isomer, and for the case where the two substituents are on the different side, is called the trans isomer. So this is the only concept behind cis and trans isomerism. For the double bonds where the two substituents they are hydrogen and the other two substituents they can be on the same side or they can be on the different sides. For the case where they will be on the same side is the cis isomer, and for the cases where they are on the different side is the trans isomer. So let's see some examples. For example, we have 2-butene. We have 2-butene. We have already discussed it in a previous lecture. So what is a 2-butene? Let's first write the simple structure. So this is 2-butene. Now this 2-butene it can occur and it can exist in two forms. The first one where the two methyl groups are on the different sides, and these two hydrogens will be like this. And the second case can be where the two methyl groups are on the same side, and then the hydrogens will be on the same side as well. So it is quite simple. If you look at the first structure, the two methyl groups they are on the opposite side, so we call it trans 2 butene. For the first case where the two methyl groups are on the same side, we call it cis 2 butene. Let's see another example. Let's say we have 1,2 dichloroethylene. 1,2 dichloroethylene. So what is ethylene, or it is ethene we can say as well. So 1,2 dichloro is means that on both carbons one each has one chlorine attached on it. So similarly two cases can occur. The first one where let's say the two substituents are on the same side, and for the second case the two substituents will be on the different side. So the first isomer is the cis isomer because here the two groups they are on the similar side. And for the second case where the two groups are on the different side is the trans isomer. Similar concept it can be applied on the cyclic compounds as well because in the previous lecture we have discussed that there are two cases in which there is restricted rotation about a single bond and in both cases geometrical isomerism is observed. So let's say we have we have 1,4 dimethyl cyclohexane. So what can happen is I'm writing it in this form. These are two cyclohexane molecules. So 1,4. For the first case, both methyl groups they are on the similar side, and for the second case, both the methyl groups they are on the different side. So it is very simple. For the case where the two groups they are on the similar side is the cis isomer, and for the case where the two groups they are on the different side is the trans isomer. So this is very simple. This is the cis trans nomenclature. Now consider an example that we have this compound. There is a alkene bond. It has chlorine attached over here, as a methyl group over here, and a bromine over here. So now you cannot apply the cis trans nomenclature on this case. For such cases, a new type of nomenclature was introduced which was named as the E Z nomenclature. For the E Z nomenclature, the priority order is used. In different books, they tell you specific like priority order and they ask you to remember it. But here I will not suggest that you try to remember the priority order. It is very simple to understand that here the priority it is assigned on the basis of atomic number. So let's discuss how to assign the E Z nomenclature to this molecule. So divide this molecule in two parts. So you have to work on each part separately. Let's say we name this part as A part of the molecule and this part as B part of the molecule. So look in the A part. Now there are two groups. The first one is the chlorine group and the second one is the hydrogen group. So which has higher atomic number? So you must know that chlorine has higher atomic number. So it will have the first priority in these two groups, right? Now let's work on the second part. Here you see that bromine has higher atomic number than carbon. So here bromine is 1 and methyl is 2. So the first step to assign E Z nomenclature is that you divide the molecule into two parts and then assign the priority orders to the substituents separately. Now see if the top priority substituents, if they are on the similar side, then it will be the Z isomer. But for the case as it is in the case of this molecule, that the two top priority groups they are on the different side, in that case it is the E isomer. These two terminologies, the E and Z, they arise from German words where the Z it represents zusammen and the E it represents antigen. Zusammen it means together, whereas the antigen it means opposite. So now recall what we were studying like 4 to 5 minutes before, that For together cases, it is the kind of cis isomer, and for the cases where the substituents are on the opposite side, we call it the trans isomer. So here, where the two top priority groups are in this case are on the opposite side, so such isomer is the E isomer, whereas in the cases where the two top priority groups they are on the similar side, we call it the Z isomer. So to assign the E Z nomenclature, you just take the molecule, you divide it into two parts, and then work on the each part separately, assign the priority orders, and then compare the top priority groups whether they are on the same side or on the different side. So let's look at another example. Let's say we have a molecule. Here is bromine, here is iodine, here is chlorine, and here is chlorine, right? So the other one is case where chlorine is on that side and chlorine is on this side. So step number one, divide the molecule into two equal parts. So this is part A, this is part B. So for the part A, you see there are two groups. First one is the iodine and the second one is the bromine. So here, as you know, that bromine has lesser atomic number compared to iodine. So the first priority will be for iodine 1 and bromine will go to. On the part B, there is the comparison between chlorine and fluorine. So you must know that chlorine has higher atomic number, so it will be given number 1, and the fluorine it will automatically get number 2. Now for the second molecule, divide it into two equal parts, part A, part B. For the first part, iodine has a higher atomic number, so it will be 1, bromine will be 2. And on the second side, chlorine has higher priority than fluorine because of its higher atomic number. So now let's assign easy. For the first molecule, here you see that the two top priority groups, the two one assigned, they are on the similar side. So they are together. So this is the Z isomer. And for the second case, where the two top priority groups they are on the opposite side, so this is the E isomer. So this is the basic concept behind the two types of nomenclature that are related to the geometrical isomerism. So in the next lecture, we will try to solve some examples related to the E Z nomenclature. Till then, see you. Allah Hafiz.